right, now we're starting Chapter 11 with Section 11.1. So our learning targets, we're going to be calculating probabilities using normal distribution. First, we'll figure out what normal distribution looks like. Then we're going to be using z-scores and the standard normal table to find some probabilities. And then we're going to be recognizing if data sets are normal or not. So the first thing, we're looking at a normal curve. Here's what a normal curve looks like. You'll see that it is a bell shape, and it has these properties. So my normal distribution with a mean of mu, this is the Greek letter mu, and a standard deviation of sigma has these properties, right? And we can go back through standard deviation, but for this, what we're looking at in this unit, we're going to be given our standard deviations. We don't have to find that from our data. So the total area under my normal curve is 1. So that can help us a lot with probabilities. So about 68% of the area lies within one standard deviation of the mean. So my mean is always going to be right in the center is my mean. So then I can calculate my standard deviations, right? So here's my mean plus 1 standard deviation, mean plus 2 standard deviations, mean plus 3 standard deviations. And then again, I have to subtract a standard deviation and subtract 2 and subtract 3. So I always start with my mean, and then I'm looking at standard deviations on either side. So 68% of all of my data will fall within one standard deviation of the mean. Then I also know that 95% of my data falls within 2 standard deviations of the mean. And I know that 99.7% of the area lies within 3 standard deviations. And this is symmetrical, so I know that 34% of my data will fall 1 standard deviation below the mean, and 34% will fall 1 standard deviation above my mean. This is something you definitely will need, so make sure that you have these numbers kind of figured out. If not these specific ones, know this, because these we can always break down and figure out from there. But this is data you will absolutely need to know. So now here's my first example. So a normal distribution has a mean mu and a standard deviation of sigma. An x value is randomly selected from the distribution. So find the probability that mu minus 2 standard deviations is less than or equal to x, which is less than or equal to mu. So I always want to kind of draw my normal distribution curve. That helps me kind of see what I'm looking at. So I'm looking at the probability that a randomly selected x value lies between mu, my mean, and 2 standard deviations below my mean. That's what this notation means. I'm finding a value that's between those two things. So now I draw my distribution curve and I see where my percentages are. So I know that it's a combination of these two, so I add these together. So 0.135 plus 0.34 is 0.475. So I know that the probability that my data selected falls in here is approximately 0.475. So I want to stop and think, does this make sense? So this is a little bit less than half, right? Because 0.5 would be half. And I see that in my curve, yeah, it's a little bit less than half because it doesn't include anything down here. So I would say that I'm on the right track. So here's our next example. So the scores for a state's peace officer standards and training test are normally distributed with a mean of 55 and a standard deviation of 12. The test scores range from 0 to 100. About what percent of the people taking the test have scores between 43 and 67? And then we're looking if at an agency will only hire applicants with 67 or greater. What percent of people make them eligible? So the first thing I always want to do is I want to draw out my normal distribution. You're going to hear me say that a lot in this unit. Draw out your normal distribution. Draw out your normal distribution. So I know that my mean was 55, and I know that I had a standard deviation of 12. So I know I'm going to take 55 plus 12, which gives me 67, and then I'm going to add 12 more, which gives me 79, and then I'm going to add 12 more, which gives me 91. So I also have to look at my standard deviations below that as well. So I subtract 12, and I subtract 12, and I subtract 12. This is absolutely where you must start with your normal distribution and when you're dealing with these problems. So my first part was asked, what percent have scores between 43 and 67? So here I see that 43 and 67 are my 1 standard deviation away from my mean, and I know that 68% of all my data falls within that 1 standard deviation away. So I can say that 68% of the people taking the test will fall within that range. So let's look at that question part B. Again, I have my same normal distribution curve. So I see that 67 is 1 standard deviation above to the right of the mean. So I can figure out how many percentage is above that. So I know that 16% of my data falls above this as well. So I know that that's going to be my final answer for this. And I can find this 16 if I don't know 16 right off the bat. I know that 13.5% of my data falls in here in the second standard deviation, and 2.35% of my data falls within this third standard deviation. And so I can add what I know, and I've got that 16% total. Again, this is one of those values that you may just want to kind of remember, that if you're over 1 standard deviation, there's 16% total. We always have to start by drawing our normal curve so we can see what we're talking about. How many standard deviations away are we looking? So here's your first monitoring progress. See what you can do for this one. So now we're talking about standard normal distribution. Here's where we're looking at some z-scores. Okay, again, so I have my normal distribution curve, my mean, and I'm trying to figure out z-scores. So a z-score tells me how many deviations away my value is from the mean. Okay, so again, if I have a positive z-score, that tells me I'm positive standard deviations away, and negative means I'm below the mean. So to find my z-score, I take the value that I have, my x value is the thing that I'm looking for, subtract the mean from that value, and then I divide it by the standard deviation to find my z-score. So now let's look at an example. Oh, we're also going to be looking at this table. This is my standard normal table, okay? So I can use this table to help me find this. So here's my example. The table shows that the probability that a z-score is less than or equal to negative 0.4 is 0.3446. So I find this, right? Because my z-scores and my standard deviations are just whole numbers, but now I can also use my tenths to help me find this. So to find the negative 0.4, I go to the negative 0, and then I go over to my 0.4. And wherever those two meet, that's going to be that probability. Okay, so another thing that's important here, this 0.000 plus means slightly more than 0 and slightly less than 1, right? Because we can never say exactly for sure 100%, but we can get super close. So that's just how we can read those. We're going to be using this table pretty often. We use it to find our probabilities for any normal distribution. So first we have to get from our distribution to our z-score, and then we can use our z-score in this standard table to help us find the probability. So here's our example. A study finds that the weights of infants at birth are normally distributed with a mean of 3270 grams and a standard deviation of 600 grams. An infant is randomly chosen. What is the probability that the infant weighs 4170 grams or less, right? So first I want to find my z-score, and for me, I would first kind of draw my distribution curve, right? So I know that my mean is 3270, and then I know I have a standard deviation of 600, so if I add 600 to that, I end up with 3870, and then I know if I add 600 to that, I've got 4470, and then I can look down here as well. So I see that I'm looking for 4170, so that's going to fall somewhere in here, right? Or less, so anything over here. So I know I'm looking for a pretty large probability. It's going to be greater than 0.5. And I just get this in my brain so I know that if I'm on the right track when I'm doing my calculations. So first I want to find my z-score. So in order to do that, I take that value that I'm given, my x of 4170, and I subtract the mean, and then I divide by the standard deviation, by my sigma. So my z-score for this data piece is 1.5. So now I can use my table and use this as well. So I'm looking for the probability that z is less than or equal to 1.5 because I'm looking at everything lower than this. So I find on my table my 1 and 0.5 meet, so my probability that the baby selected, it weighs 4170 grams or less, is 0.9332. And again, we can just check using our calculators and to figure out the area. Or we can just know that, yep, I was pretty close because I know it's more than 1 standard deviation, but less than 2. So just based on some just general observations that I made about the data, I knew I was pretty close. So now here's your next monitoring progress. See how you can figure these out and what you can do with them. So now we have to look at that third learning target and how can we recognize if distribution is normal. So not all distributions are normal, right? Look at these here below. This is what we're talking about, our normal distribution. So it's a bell shaped where it's highest in the middle and then it tapers off on both sides. So in a normal distribution, my mean is my median. They're right together at the same point. So I can also have data sets that are skewed left and skewed right. So if my data set is skewed left, I can definitely see this is not normal distribution. So I know here that my mean is going to be less than my median. And if I'm skewed right, my mean is going to be greater than my median. Just if I was to look at where my data points would lie, this is how it would kind of look. So we have to look and see if I have normal distribution or if it's a skewed distribution. So here's our example. So determine whether each histogram has a normal distribution. Okay, so I can look at this first one and kind of see the shape of it, and I see I go up towards the middle and then I come back down. So I would say that yes, it's pretty symmetrical, so I do say that it is approximately a normal distribution for A. So for B, I see that I'm definitely higher up at the beginning and then it tapers off towards the end, so I would say no, this is not a normal distribution. It is skewed to the right, so it's not normal. So I can't use my normal distribution and I cannot use z-scores to interpret the histogram. I have to find other ways to look at this data set. Whereas this first data set, since it was normal, I could find standard deviations and I could find z-scores to analyze it. So now here's your last monitoring progress. What do you think about this graph? Is this normal or not? So now we're going to look back at our learning targets. First thing we did was calculate probabilities using the normal distribution. Make sure you have this information written down as you're going to use it over and over and over again. So then we were able to use that and some z-scores and the standard normal table to find probabilities. And when you're testing, I'll make sure you have a standard normal table to use as well. Then we looked at different data sets and how they look, and we could tell just by looking at the histograms if my data sets are normal or not. So now that we've looked through all of our learning targets for 11.1, go ahead and start working on the homework.